Hi, everybody. I'm Luke Bruneau. I graduated in 2013 in physics. I spent most of my time at the Bauer Center, which was called at the time at the Northwest Building in Integrative Science. I just want to echo what was said up here. I am extremely grateful for Dean Dench and for John's leadership, as well as to the staff. They do an incredible job. And while I'm up here, I just want to do a pitch for the council. It's been wonderful to be on. This is the end of my first term. And given everything we've heard about the stress and the ups and downs of having a PhD, getting a PhD, and what comes after, it's been really great to reconsider my time here through that lens and to be aware of that folks were looking out for me. And maybe I didn't realize that there are people who are looking out for my well-being and my future and my success. So I'm grateful for this experience. And as a data scientist in healthcare, I'm extremely grateful to be introducing the panelists here, the transformative impact of AI on medicine, education, and the economy. So we're going to have 3 panelists, and each of the panelists will come up and give a short presentation, about 10 minutes. And then after that, we have some Q&A, and we'll take some questions from you all as well. So I'd like to introduce and go through the bios of the 3 panelists, and then we'll have our first presentation. So Teddy Svoronos, a PhD 16, is a senior lecturer in public policy at the Harvard Kennedy School, where he teaches courses on quantitative methods, generative AI, and evidence-based policy. His work focuses on leveraging technology to small-scale, interactive classrooms to learners around the world. His research involves the intersection of pedagogy, technology, and the adoption of evidence. Teddy is a co-founder of Teachly, a web application focused on creative, effective, and inclusive learning environments, and PingPong, a platform leveraging generative AI to create custom bots and other unique learning experiences. At HKS, he serves as the faculty lead for the evidence for decisions area of HKS's online public leadership credential and the school's faculty liaison for pedagogy, and digital learning. Teddy received his PhD in health policy from Harvard University and his master's degree in public health from Columbia University. The second panelist, Marinka Zitnik, is an associate professor of biomedical informatics at Harvard Medical School, associate faculty at Kepner Institute for the Study of Natural and Artificial Intelligence at Harvard, and associate member at the Broad Institute of MIT and Harvard. Zitnik investigates foundations of AI that contribute to the scientific understanding of medicine and therapeutic design, eventually enabling AI to learn and innovate on its own. Her research won Best Paper in Research awards, including the Cavell Fellowship of the National Academy of Sciences, the Knibb Fellowship Award at Harvard Medical School, the NSF Career Award, awards from the International Society for Computational Biology, International Conference in Machine Learning, the Bayer Early Excellence in Science, Amazon Faculty Research, Google Faculty Research, Roche Alliance with Distinguished Scientists, and Sanofi Idea iTech Award. Zitnik founded Therapeutics Data Commons, a global open science initiative to access and evaluate AI across stages of development and therapeutic modalities. And she served as the faculty lead of the AI for Science initiative. She is the recipient of the 2022 Young Mentor Award at Harvard Medical School. And finally, Jason Furman, PhD 04, is the Aetna Professor of the Practice of Economic Policy, jointly at Harvard Kennedy School and the Department of Economics at Harvard University. He is also a non-resident senior fellow at the Peterson Institute for International Economics. Furman engages in public policy through research, writing, and teaching in a wide range of areas, including U.S. and international macroeconomics, fiscal policy, labor markets, and competition policy. He co-teaches Ec 10, Principles of Economics, the largest course at Harvard University. Previously, Furman served for 8 years as a top economic advisor to President Obama, including as the 28th chairman of the Council of Economic Advisors from August 2013 to January 2017, serving as both President Obama's chief economist and a member of the cabinet. During this time, Furman played a major role in most of the major economic policies of the Obama administration. Furman also served under President Clinton. Furman is a member of numerous organizations, including the Council on Foreign Relations, the Group of 30, and the Economic Strategy Group. He also served as a trustee of the Russell Sage Foundation and on the advisory boards for the Brookings Papers on Economic Activity, the Bunn Summit, the Hamilton Project, and the Washington Center for Equitable Growth. In addition to articles in scholarly journals and periodicals, Furman is a regular contributor to the New York Times and Project Syndicate, and the editor of 2 books on economic policy, and his PhD is from economics at Harvard. So please welcome our first presentation from Teddy Svoronos.
Hopefully we can do better than that. I'm getting flashbacks to being a grad student and half the class being asleep. My name's Teddy. I'm here to talk about teaching and learning in the age of AI. I don't usually title my presentations with a reference to Charles Babbage, but I feel like maybe in this company it's more appropriate with the historians and mathematicians and so forth in the audience. I want to start, before I talk about teaching and learning, talking about what has changed in AI and generative AI since roughly the end of 2022, early 2023, because I think there really has been quite a few that have been quite significant in the commercial space, especially around November of last year. I'd say there was like a step change in what was possible. So previously, you might recognize an interface like this, ChatGPT. You go to it, you say, help me draft a presentation. It helps you make an outline. You give it feedback. It sort of like has this back and forth text thing. And then you get your text and you can go and do it to what you want. Since roughly November, there's been this thing that has been getting a lot of press called agentic AI. And I want to give you a look about what that actually looks like in practice. So this is a screenshot of Claude Cowork, which is one of the agentic AI systems that this is a screenshot that may or may not have led to the creation of this presentation. I want to give you a sense of what's possible now. So a couple of things. First, if you look over there on the right, if you look over here on the right, it is capable now of planning. So it creates a task list for itself, and it goes through each task, and it has long-term planning, and it can sort of make sure it's doing each of those things. As I asked it to work on new slides, it ran 6 sub-agents, by which I mean the AI itself spun up 6 individual AIs, each to go work on their own slides, and then come back to it with their results. It was then able to actually visually inspect the thing that it produced and then iterate on it and create sort of newer and newer and better versions of what it initially produced, because the first draft wasn't very good. The last draft, I'd say, was pretty good. So this difference, I think, is really quite important. So the 3 biggest things that are new, I would say, with respect to agentic AI is, first, you're not just interacting with it in a text sort of exchange. It's capable of interacting with the world. It can manipulate files. It can go on the web. It can, interact with websites and things along those lines. It's capable of planning. So longer term, multi-hour long tasks it can now work on instead of just this immediate back and forth. And then finally, this is the thing that I think is most interesting. It's capable of iterating in a loop. So it'll use a tool to do something like make a slide. It'll inspect that. It'll evaluate it, and then it'll continue to iterate over and over and over again until it's satisfied with its result. That ability to iterate, I'd say, is new enough that it kind of changes what's possible. So, it made me a presentation. That's great. Well, how does this actually matter for teaching and learning? This is David Yanagisawa-Drat. He's an economist. He didn't go to Harvard, so he's not here, unfortunately. But I want to show you a Twitter video that he posted, and I'm going to read it to you because the resolution is quite low. It says, I always dreamed of becoming a macroeconomist one day. I need a job market paper desperately. Since I only know applied micro, I need your help. Find a novel angle. I don't really know what macro does these days. Maybe something about labor. I think we need a model. Most job market papers do. And we need, 48 plus pages of beautifully written prose maps and so forth. And then he left. And in that process, the model looked at the literature, found something that it thought was worth investigating, acquired data, went on the internet and got the data that it needed, wrote a bunch of code to analyze its sort of research plan, developed a research pipeline to be able to analyze its content, and then produced a pretty, passable paper in that it has not only just sort of like its contribution, it has sort of like the full theoretical model behind what it's doing. It does robustness checks on the actual data. I'll leave it to Jason to decide whether this is actually useful macroeconomics work or not. But the fact that it was able to produce this paper is, I think, quite interesting and important and changes the conversation around teaching and learning. Because up until this point, and still kind of is in popular discussion, the real question is, are students learning? Are they just using AI to do all their work for them? I think this changes it in some way, because it's not just that these tools can do homework, they can do work. They can do the actual jobs that we're trying to train people to be able to do better, or at least accelerate the work that they do in some way. And so while we have this kind of narrative about people using AI to cheat and so forth, there's these sort of sea changes happening in different areas of the world in terms of the work that's possible. The kind of existential crisis that I think a lot of writers had in early 2023, when these tools could sort of write prose and edit things and so forth, is now kind of happening to the whole field of social science in a way that I think is quite profound and has a lot of implications. So this really does beg the question, what is it that we should teach? Not just are students learning the right things, are we teaching the right things? What does it matter to teach in a world where AI is increasingly able to do more and more of what it does? And to this, now I'm going to get back to Charles Babbage. So Charles Babbage, mathematician, philosopher, maybe the first computer scientist, produced this analytical engine. It was sort of one of the proto-computers in the 19th century. And he sort of showed it off to Parliament and all the things that it can do. And there's this quote that he says, on 2 occasions I've been asked, "Pray, Mr. Babbage, if you put into the machine the wrong figures, will the right answers come out?" I'm not able rightly to apprehend the kind of confusion of ideas that could provoke such a question. So I really like this quote because it's funny, but I actually think it really encapsulates a lot of what is interesting about this conversation right now, because the model that these two people kind of had that kind of made Babbage so confused is this notion that you could maybe give a machine the wrong figures and get the right answers out of it. And I think there are 2 ways of thinking about the challenge of teaching and learning now as these machines kind of exist. And I'm going to sort of put things like Claude Code and ChatGPT Cowork in this sort of space of this analytical engine. One side says that the problem with this sort of flow is that we're giving it the wrong figures. We need to really focus on making sure that our students and the world can ask the right questions to these machines. And that involves doubling down on the expertise that we've been trying to teach our students for a long time, that we're trying to develop in some way, the kind of judgment that we think is a really important part of higher education, right? The alternative is that what we should really be focusing on is how these AI tools work and to train students in what we call AI literacy now of how to actually use AI more effectively. And if we do one of those 2 things, or maybe both of them, we'll then get better at sort of getting the right answers in a way that matters for the world. Now, my personal view is that, well, actually, hold on. There's a third view that says none of this matters. This is the first ever machine that actually can give you the right answers to the wrong questions, because it can figure out what your question actually is, even if you're giving it the wrong one, and figure that out and actually manipulate in some way. So maybe those 2 people actually right. They were just 200 years early. So my view is that this first view of that all that matters is domain skills and expertise is sort of under-updating our priors about what matters in the world. On one hand, this domain expertise is really important. On the other hand, I've seen people who are much, much, much smarter than me use AI in ways that completely misled them and led to completely bad output that they couldn't use in the world at all. So it can't just be the case that domain expertise is all that matters. On the other hand, I think the AI literacy sort of group is over-updating. The notion that domain expertise is no longer important is, at least for now, wrong. That is to say, the kind of stuff you can get from these tools is very, very contingent on the development of actual good judgment and expertise that is sort of independent of the tools themselves. So I want to talk about these 2 things. Developing domain expertise. I think it's worth thinking about what skills we want to develop without AI. So I think the notion of friction to learn judgment, the kinds of things that everyone in this room did when they were graduate students that they were so annoyed by at the time, but now in retrospect say, oh, I'm so glad that I did those things still matter. And I think there's actually real sort of cognitive research and learning research to suggest that the friction is the point. The friction is the way that we develop the kind of expertise that we need. I also think there are some versions of domain expertise that we can develop with AI, but only in very specific, narrow, sandboxed ways. So Shard Goel, my co-creator at the Kennedy School, we made this platform called PingPong, where you have very narrow uses of AI. For example, in this case, it's very small. This bot is something I made in my stats class that will drill students on a subset of skills that they need to learn, and it will keep giving them problems. It will make it harder or easier depending on what they want. But the goal is to develop that expertise, that intuition to be able to understand what a problem is asking for in the moment, right? Then there's this notion of learning these AI tools well. And this new AI literacy thing is, I think, something that is developing quite a bit now in sort of agentic time, which is to say, these are the skills that matter, I think. Not just how do you interact with an AI, but how you think with these tools. So the most important one, in my view, is this notion of managing cognitive debt. So I define cognitive debt as the distance between what the AI actually did and your understanding of what the actual AI did, right? That difference is cognitive debt. And we think of that as a bug, but it's actually a feature. The point is that we are offloading information to another tool to do what we want faster. And as an economist will tell you, debt isn't necessarily bad, provided you can pay it back, right? So this notion of being able to figure out what to offload and when, and how to make sure you're not getting so far away from what's happening that you can no longer really sort of follow the plot is, I think, a new skill that we need to develop in our students. This notion of verification first analysis is very common in the social sciences. The idea that you simply need to pre-specify what you think, what you're going to do to test the results that you have before you actually do the analysis to make sure you're not just sort of getting around the fact that you're getting what you actually want through phishing. This is actually now important in every AI interaction that you have. I think it's important to be able to figure out how you will evaluate the output of the AI before you ask the AI itself. Because if not, this notion of psychophancy and the things that you see in AI become a big problem. And then finally, traceability really matters a lot now that we have many, 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 many agents doing work for us instead of a single ChatGPT thread. I think that changes quite a bit in the world. So the ongoing questions, I think, that are worth really figuring out now as we get back to this notion is, first of all, yes, domain expertise matters, but does the nature of what domain expertise means need to change? Are there some things that we taught because they were proxies for domain expertise that are no longer good proxies for them? Or are there things that we need to newly focus on that we didn't focus on before? And secondly, this AI literacy stuff, like I said, since November, I think things have been very different. And trying to figure out how we can remain relevant is, I think, a really important thing as we try to focus on developing skills in these tools. And the final one, this is the thing that literally keeps me up at night, is to what extent will learning one take away from your learning of the other, right? To what extent does using one of these tools erode your domain expertise and vice versa? And how can we manage that as people, not just teaching students, but people in the world trying to learn and do better in the work that we do? With that, I will turn it to the next speaker, which I think might be Jason. Jason, please.
While you're getting up, I'm going to do something that's not really customary. And while Teddy's slides are much better than mine are going to be, they really weren't nearly as good as they could have been. They weren't nearly as good as they could have been because the due date for the slides was Wednesday. Claude Opus 4.7 came out on Thursday. Claude Design, a new thing to design your slides, I believe came out on Friday. And had he done this on Friday, those slides would have been twice as amazing as they were, or maybe even amazing squared instead of just amazing. That would be the first thing I would say. The second thing I would say before I get to my presentation is I think we're living in a world where some people have seen these tools and some people have interacted with a chatbot. And those are two entirely different universes. I was in a meeting a few days ago about how to handle AI with our assignments for undergraduates. And somebody said, oh, I have an assignment and it's AI proof. You have to build a dashboard with certain indicators of a housing crisis and write up something that describes what's in the indicators. In meetings, sometimes people pick up their phones and check their texts and do emails. I did that, but I didn't do it for very long. I did it for about 30 seconds. By the end of the meeting, I had a website with 12 different charts or so, interactive dashboard, red, green, and blue for whether a housing crisis was coming, and a write-up that I shared. That was based on about 4 sentences of text that I typed into my phone, asking it to publish that website. So what I'm doing now with anyone who hasn't seen the other side of it is something like that. My brother's a federal judge. I wrote yesterday 4 different papers that compared him to all the other judges in his district by downloading and reading all of his decisions, scoring them in various ways, looking at the time he takes for his decisions, how often he's overruled compared to others, with dozens of charts based on this analysis. I think he's now in that mindset too. So I'd encourage you all to, it's getting actually easier and easier to do all of this. Get a paid tier, maybe even pay $200 for a month. Experiment with it. There's a whole world on the other side of this. Whether it's a good or a bad world, I'm less sure, but there's a whole world on the other side of this. I would also say, by the way, for at least our undergraduates, the variance is enormous. I was talking to one student yesterday who never uses any LLMs even, just afraid of it, thinks it's bad, believes in her craft as writing. Some ways I respect that, and I think you can get a lot out of being an undergraduate with that mode. There's other students that have sort of 8 agents, well, that's an understatement, 80 agents going at the same time simultaneously. I think as a PhD student, you have to be in that second group while you need to like struggle through stuff, work through it. If you're not taking advantage of these tools, you're not going to be able to discover new things, advance knowledge in nearly the same way. And the hope for me of what comes out of this is not that our PhD students are like me, having written 4 legal papers that I didn't understand yesterday, but write sort of more amazing papers that are more creative. So now let me talk about what I was going to talk about, having been distracted by that, which is AI and the economy, threat, opportunity, or both. There's been a long-standing concern, there's a concern that the robots are going to take all our jobs. So here's 2026, Fortune magazine. Scientist who created AI says it's only a matter of time before every single job is wiped out, even safer trade jobs like plumbing. It's a long-standing concern. In 1980, the New York Times had an article, "A Robot is After Your Job." 1960, this is the Wall Street Journal. They at the time were actually concerned that the robots would not just take jobs here in US factories, but also eliminate all the jobs in outer space. These are nevertheless true robots, automatic devices that perform human functions or operate with seemingly human intelligence. 1935, Washington Post, thinking machines replace the thinkers. They predict tides, pick criminals' fingerprints, calculate mathematical problems, and perform amazing tasks. Robot brains outdo man's mind in speed and accuracy of results. And then we'll sort of leap back to 1812. This is the Luddites and a poster for them. So we have had a long-standing, deep-seated view that whatever this technology is, it's about to take our jobs away from us and won't leave us with any other jobs. Now, if you look at the economic data, I did promise you this was worse than Teddy's, and I think I'm delivering on that. This is the unemployment rate in the United States, and basically it's been, around 95% of people that want to work at any point in time can work. When it goes up, it's not because we discovered some new thing, but it's because we completely messed up our monetary policy or something that we teach in a macroeconomics class. So fluctuations in the unemployment rate have nothing to do with technology. They're something else. Why is that? Well, it's not because we haven't innovated. All the people talking about the robots, the amazing things we were going to do were right. If we wanted to work 1/10 as much as we did in the year 1900, we could have exactly the same living standard that we had in the year 1900. And we could work all, 3.5 hours a week, or 1 out of 10 of us could work, or we could work for 4 years of our career rather than 40 years of our career. That's not what we've done, as you see in the right-hand chart. Number one, our living standard is 700% higher. The second is it doesn't look a lot, but the average annual hours per worker is down, I think, about 40%. Moreover, the way retirement used to work is you died and then you retired, so you didn't really get to enjoy it. Now, usually you retire and then you die some decades later, which is more fun. So why is it looks always like these inventions are going to take our jobs, but they don't, over and over again? First of all, they don't necessarily kill jobs, not necessarily, in the innovating sector, and I'm going to go through all 5 of these. And then second, even if they kill jobs in the innovating sector, they don't do it economy-wide. So why has this been? These numbers, some of them are made up, but they're not totally crazily made up numbers. So let's think about farmers, first of all. 75% of us were farmers in 1800. Now it's 1% of us. Farmers today can grow about 100 times more food as they could in 1800. So 1/75 the farmers, 100 times more food per farmer, we're eating about 1.3 times more than we did in 1800. It shows, but it's not sort of that much more than we were eating back then. Now let's look at accountants. This is sort of a guesstimate, is that 1/10 of the population was accountants in 1800. It's not a crazy guesstimate. It's probably lower than that. It's definitely not higher than that. 2025, it's a real number, 8/10. So we have 8 times more accountants than we used to have. Accountants can do, this is a real guess, about 1,000 times more per hour as they could 225 years ago. In terms of like addition, subtraction, multiplication, they can do millions of times more hours in terms of recording things, correcting them, but you also have to talk and think and stuff like that. So what does that mean? We're doing 8,000 times more accounting than we were doing in the year 1800. Now, if you went back to 1800 and told people you were going to make the most amazing machines that could do the most amazing accounting, I think they'd say, like, that's really cool, because, like, in addition to all the accounting I'm doing now, here's like 3 other things I would do, and maybe we could do 50% more accounting. Maybe we could do twice as much accounting. The idea that you could do 8,000 times as much accounting as they were doing then sort of blows the mind. Some of it's sort of because of our tax system, but a bunch of it is like better planning, better allocating of capital, better making of decisions. And by the way, after Lotus 1, 2, 3 was introduced, the number of accountants went up, not down, because accountants were able to do more. So what does this say? One thing that matters when you innovate, does it create jobs or lose jobs? If you don't want to buy much more of the thing, it costs jobs. If you are like excited that the person can make more and now you want to buy even more of it and the price goes down, then you actually create jobs. And so this, you can call it the elasticity of demand, matters quite a lot. And we often underestimate, we think things are like food when a lot more things are like accounting. Second, ChatGPT did this one for me. I'm getting, and like eventually we'll be like Teddy. Jeffrey Hinton, who invented an awful lot of what we're talking about, or some of the key things for it, a decade ago said stop training radiologists now. In 5 years, deep learning will do better than radiologists. We have 20% more radiologists than we had when he said that. Why? What does a radiologist do? They read scans, they talk to patients, they talk to other doctors, they worry about billing, which, by the way, AI is like not good enough to deal with yet because it's so complicated. That's going to be the last thing they automate. And it's this bundle of tasks. And yes, you can do one of your tasks better, but you have all these other ones together with it. And by the way, the radiology AIs are quite good at certain types of things, but not all things, and don't quite know which one to use. So it replaces tasks, not workers. Now, the Luddites weren't totally wrong. Sometimes automation does destroy jobs, but it also creates new jobs. If you would ask somebody in 1926 how many people are working in cybersecurity in 100 years, they would have looked like that man looked. And there's 1 million people working in that job. In fact, half of today's jobs are categories like cybersecurity that just didn't exist and were unimaginable in 2026. It's not just that, though. Richer people want more of all sorts of things. If you ask somebody in 1926 how many leisure and hospitality jobs would there be in 100 years, this is a made-up number, but like 8 million would not have been a bad guess if you told them the population in the year 2026. That's basically the same share as in leisure and hospitality. There's actually 17 million. We eat out and travel in a way that would be unimaginable to people 100 years ago because technology made us richer, so it made more of old types of jobs. The final thing is wages adjust. Sometimes your wage goes up because you're complemented by technology. Sometimes it goes down, but either way, it helps the market clear. So I think we can now understand why people have been so pessimistic for so long. There's a bad news bias. There's an inability to imagine that we just sort of want to consume more and more and more and more. It's hard to imagine new types of jobs. And then that last thing about the wages adjusting and more old types of jobs, that's what we in economics would call general equilibrium. That something changes here, something else moves there to keep the system. Now, having said all of this and been completely persuasive and convincing, let me just say I'm 100% that everything I just, sure that everything I just said is true about the past. I think it's worth taking it very, very seriously for the future because people have made this mistake over and over and over again. In general, trying to predict when things are going to be different in the future and break in some way, people sort of over-predict that. All of that being said, I'm quite nervous about this and unsure about where we are right now. And the last class of the semester in Ec 10, I'm going to give this talk. David Laibson, who I co-teach with, is going to give why the future is going to be different, and then we're going to discuss it. So I'd invite you all to that. But I won't read all of these, but basically the biggest thing is with a really, really rapid pace of adjustment, do some of the mechanisms I talked about sort of break down in the short run? Do they break down in the long run? Things like general equilibrium, wages adjust, but what if wages want to adjust to be a negative number? That's what happened to horses. That's why they're not working anymore, even though they're willing to work for free. Are we the horses? Some of this also is going to depend on policy. If the income gains from AI go to one person, they can only eat out and travel so much. It's not going to be a lot of jobs created by that. If the gains are shared, either because of the way the technology functions or what we do with the tax and transfer system, that would be a different story. And so I think you should take very seriously why people have gotten this prediction wrong over and over and over again, but be open-minded and uncertain about the rapid pace of change we're seeing as well. Now I look forward to you.
Hello, everyone. Very excited to be here with you today. And I want to share how AI is really transforming scientific discovery and biomedical discovery in ways that was unimaginable just a few years ago. So in my group specifically, we are building what we call AI scientists or AI co-scientists with the overall goal and vision to make a leap that will help us move from human-only science to human AI co-science. How do we think about that? So we think about that by developing models that are emerging conversational AI systems. You have seen a number of examples of chatbots and agents, but those are not just chatbots and not only agents that would be reading scientific literature, but instead they can do many other tasks. They can analyze clinical research, experimental data, generate scientific hypotheses, come up with rival competing hypotheses, prioritize, refine them, and integrate with experimental systems. So AI co-scientists serve as collaborators to human researchers. And they do so by leveraging and querying and executing the kind of tools that human researchers already leverage and use in their everyday work. And they collaborate with human scientists to generate better ideas, to create plans for experiments that can be then made in clinical environments or in wet lab settings, and then can integrate feedback from humans and feedback from new experimental data as it's being generated into its own reasoning for the next round of iteration. So this all sounds great and fantastic. How far away we are from realizing that in scientific discovery. I'll show two vignettes of what is possible today. So the first scientist that I will highlight is an AI scientist that we have developed for therapeutic reasoning. This is a scientist that we call TX agent, which stands for therapeutics agent. It is a model that has been trained at the GPU cluster of Kempner Institute in collaboration with a number of partners from Frontier AI Labs. Conceptually, you can think of TX agent as a conversational AI system where a human researcher would start by describing a particular therapeutics objective, perhaps a disease that they would like to develop a treatment for. And then the agent would go and perform that analysis, perform a variety of different kinds of analysis in order to complete that objective that humans have challenged the agent with. What is this useful for? This is useful for what we call open-ended research, meaning that we're not limited anymore to necessarily using the agents to help answer questions about predefined concepts or predefined diseases that might need to correspond to standard established clinical vocabularies, but instead really across a variety of complex medical scenarios, the agents can integrate all of the clinical insights developed over the last century or so. It is highly can be highly personalized, meaning that this agent can be tasked to create and solve mysteries at the level of individual patient and their specific complex medical scenario that they might be facing with. And this model performs particularly well when compared to frontier large language models, to frontier agents and frontier reasoning models. And this is possible because the agents can leverage the kinds of tools that human researchers would do. So this is just an example plot of how we can task TX agent to autonomously generate entire drug prescribing cards. So upon new approval, the FDA will publish a documents of many dozens of pages long that describe how this new drug that was just approved, how does it work in humans, what kind of adverse events does it lead to, what diseases has been indicated for, what diseases might have been contraindicated for, what are results of animal studies, what are toxicology results, etc., etc. And so these documents have various types of sections. And so what we have shown here is that we can task agents to completely generate the information for those individual sections in drug prescribing cards for new drug approvals, those that were approved after the agent has been developed and trained. And it's promising to see how TX agent here, shown as gray bars, performs high across many, many different kinds of reasoning about drugs. Does it work in practice? So here we have been collaborating with Chan Zuckerberg Initiative, and specifically the RARAS-1 network, which is a network of 97 organizations around US. Each of those organizations is a disease-centric foundation that is running discovery programs to develop drugs for diseases for which currently are no good treatments for. And so what we wanted to do is to see whether TX agent can generate useful therapeutic hypotheses for these diseases for which there are no good treatment options. And so what have we done? So first, we have made TX agent available to those disease experts across these organizations and did a blinded test. Blinded test was that we ask disease experts to pose the therapeutics objectives that are relevant in the context of their organization to our agents, and then they were presented with response generated by the agent. And so they might have seen two responses from model A and model B without knowing which is the response generated by an AI scientist versus response generated by human researcher. And then we asked them, can you score the two responses? And so what we have found here on the left, on the right, you can see that the responses generated by this AI scientist model, shown in green, as green dots, have been scored as favorable over responses provided by other human researchers across key elements of quality, including how accurate and complete they are, has any clinically relevant information, for example, be omitted from the response, is the output clinically relevant, is the content accurate, how well does it align with clinical research consensus, and so on and so on. And so that result has actually encouraged us to do another thing. And so here we actually connected our TX agent with a large electronic health record system with the access to over 5.4 million electronic health records. And so now this agent operates, it crawls electronic health records and generate new hypotheses, specifically the kind of hypothesis about adverse events that the individual patient might be exposed to that have not been recognized during drug development or drug monitoring phase. So the way this starts is that the agent would identify in a kind of self-emerging, non-instructive manner patient populations that might be described by patients that have specific primary disease, here hypertension, potentially comorbid disease, gout, and they are taking diuretics. So the TX agent would then reason through this complex medical scenario and nominate and identify, are there adverse events that of the drugs that patients are on that these patients might be at higher risk for, that go above and beyond what we know from drug labels, what we know from clinical trial study. So how can we actually test that? So we have actually asked agent to generate lots of those hypotheses, and then we emulate virtual clinical trials using these electronic health records. So what I can show to you is like a few examples. So here for TX agent predicted that patients with hypertension, gout, and taking beta blocker drugs are at increased risk of kidney failure. And so it's a novel hypothesis. We cannot see whether it's true by simply going to drug label or results of clinical trial that was not observed there. But when we look at real world data, patients really taking these drugs over entire population level, we might see these type of risks observed in real world patient data. And indeed here we can see that the prevalence of acute kidney failure in this specific patient population is higher than what we would expect had this factor not been accounted for and cannot be explained by a variety of other confounders. In another instance, the agent identified hyperkalemia also as an increased risk for those on this type of class of drugs, which we also were able to evaluate by emulating a virtual clinical trial based on real-world evidence data. And then more and more and more. So we actually have now, in a continual manner, the ATX agent crawling a large electronic health record system, generating this type of hypothesis, validating them through emulation of clinical trials, and then those that are most promising, deferring them to human researchers for deeper mechanistic study. I promised 2 vignettes, so this was the first one. This was about TX agent that is focusing on identifying and better understanding how safe and effective existing drugs are on the market across the span of all drugs developed in the last century. I'll end on with a second vignette. And so this vignette describes an AI scientist that we have been developed for neurology and neurological diseases. Such an important disease area for which the path from primary basic science therapeutic hypothesis to drugs on the market available to patients is incredibly lengthy. And so we wanted to see to what extent AI scientists can help shorten that process. We have developed an AI scientist that we call here Proton. And so with the way Proton operates, it operates by creating a constellation or a structured representation of all of data across neurological diseases that spans from molecular interactions to cellular environments in which interactions between different kinds of molecules such as proteins take place. And then from those cellular environments and cell types in tissues all the way to organization of the entire human brain and the symptoms that are observed in patients having various types of neurodegenerative diseases. And we used Proton, a single model, in collaboration with dozens of labs across Harvard and internationally, to test whether Proton can generate predictions for Alzheimer's, bipolar, and Parkinson's. And our collaborators who have run experiments prospectively to validate novel predictions made by this model. I'll just briefly mention 2, one on Parkinson's and one in bipolar. So in Parkinson's disease, Proton has nominated genes that would play a role in the health of dopaminergic neurons, a critical type of neurons for that are influential for the onset and progression of Parkinson's disease. And the way this was done is by Proton really go through each and every gene on human genome, 20,000 of them, and it ran an agent on that gene to analyze all the data about that gene, and then repeat that for 20,000 genes, and then rank and score that list of 20,000 gene results to produce what we call a genome-wide screen done by this AI model. And so we have done a number of those genome-wide screens all in silico. Well, are these genome-wide screens of any use? So then our collaborators went into the lab and they have actually performed experiments in the wet lab by knocking out those genes that Proton predicted as being most relevant for the survival and health of dopaminergic neurons that play a role in the molecular interactions involving alpha-synuclein, one of the critical protein in Parkinson's as well. So what we have seen is, with the agent here in purple, red, and blue bars, the yield improvement in the hit rate, so the number of those genes that were identified by Proton through in silico screening of the human genome over what we would be able to find if our collaborators would have to exhaustively knock out each and every of the gene or test many experiments has been substantial. And so it helped characterize faster a role of a new candidate gene in the development of dopaminergic neurons and alpha-synuclein interactions. And I'll end with bipolar disorder here for Proton. And I think this is particularly exciting proof of concept that we were able to pull together in part because of the incredible interdisciplinary nature of our university. So here specifically, we were looking into bipolar disorder and specifically subtype of it that's affecting patients who do not respond well to primary care for bipolar, which is lithium. And so we wanted to use Proton to see whether can it predict drugs that might potentially be effective for this subpopulation of patients that do not respond well to standard of care, creating a significant unmet clinical need. So Proton parsed through all of the approved molecular structures of approved drugs and filter them down from 8,000 to 200, from 200 to 57 through additional review by agents and large language models. And then through human AI collaboration campaigns, we arrive at one of those predicted drug. So our collaborators then at Mass General Brigham and Wyss Institute have went to the Center for Bipolar Disorder, collected blood samples of patients who do not respond well to standard of care treatment. And they grew brain organoids from those samples. And they treated them with the drug predicted by Proton. So what you can see here on the left is actually that's how these organoids look like. What you can see on the right is a heat map or a table where every column is one organoid. And so this blue-red patterning of that heat map is the proteome readout generated from that organoid. So what is interesting here to see is that we have organoids grown from healthy controls. Those organoids in red here columns that are organoids grown from patients with bipolar disorder. And in green are organoids from patients grown with bipolar disorder, but were treated with this drug that Proton predicted. And what you can see is the shift of the red patterning in green towards the blue color, meaning that the drug predicted by an AI model showed to partially restore the proteome of organoids derived from patients with bipolar. We have multiple lines of evidence across multi-omic data now to support this insight. But you can just imagine what kind of AI human experiments, collaboration campaigns, and discovery loops are possible now by developing these foundation models and agents, use them to generate new hypotheses, test those hypotheses in the lab, generate new data, and run this across multiple interactions. And this is happening. This is the reality of what we can do today already. Okay, taking a look ahead, right? So lots have been mentioned about these more complex multi-agent systems where we do not have just one agent or a single thread or single chatbot doing the work for us or answering questions that we might want to ask, but really collaborative nature of agents. And so kind of thinking a lot about this problem, there is an opportunity to now begin leveraging and developing these models for scientific discovery to run over extended period of time, and also agents collaborating with each other, potentially in ways like that human researchers collaborate with each other to refine their ideas to have discussions. And so what we have built is a kind of social network for agents. So if you go to CLO Institute as aiscientist.tools, we have currently 110, but this was generated from earlier this week. So it's around 200 agents who are running continuously. So 24/7, they are running for several weeks already. So what are they doing? They are solving big open challenges and questions in biology. So here is, for example, we gave a problem to these to agents to optimize the functionality of a protein by nominating specific mutations that should be done in it in order to improve the functional properties, stability, and binding affinity to its targets. And agents engaged in this multi-round exchange of information, multi-round campaign to arrive at a very actionable hypothesis, an experimental assay plan that has now been sent to experimental validation. So every student in my group now has a team of agents who work with them, and they work 24/7 to generate, refine the data, generate and evaluate hypotheses, and they are collaborating with each other, the agents and humans, the way we would hope the future will, the way we scientists know how to do in our everyday work. So with that, I'll conclude, and I'm happy to take any questions in the session that's coming up. Thank you.
Thank you so much. Give everyone a round of applause for those amazing talks. So we'll go through some questions I have here first for the panel, and then we'll open it up for a couple questions from the audience as well. I found all those really fascinating. I know the most recent talk in the lab, I would have loved to have aided design and collaboration with an AI, and I certainly would have loved to have someone to read all the papers I had to read. So for the first question, this is for everyone. How has the spread of AI and other digital technologies changed the skill requirements of jobs in your fields, respectively? And what can't be replaced by AI, if anything? So open to the group.
Happy to start. So, in the context of AI for science or AI for scientific discovery, I think there are three big considerations that are still uniquely human. So the first one is that of asking the right research questions or posing important research questions. By that, I mean contextualizing that the kind of questions we would want to pass agents to generate hypotheses for are tied to biological and clinical relevance, to address those questions that are associated with unmet clinical needs, with lack of medical, broader scientific understanding. And so that type of contextual information that exists, that we as human researchers have, is not something that agents would be able to easily grasp and understand. The second is that of interpreting outputs in the face of uncertainty associated with data and the fundamental stochasticity of biology and biological systems. So you might see some of these systems produce outputs, and they're very confident in the outputs that they produce. And so it is then on human researcher to judge the output and understand that, well, the output that was generated might have used data from an experimental assay in, for example, biological system or organism that is less relevant for human or potentially has high false discovery rate. And so this understanding of these uncertainties that are associated with the data, and the model, and just the stochastic nature of biology is also an important consideration. And then the third one relates to think about how to make the outputs of these models actionable in real world. And by actionable in real world, I mean the outputs of these agent systems for scientific discovery are actionable if they can translate to inputs in experimental wet labs or to inputs in tools and systems that clinical researchers often use. And so there is this big gap or divide that not many are actually working on, because researchers would either focus on developing core AI methodologies and training foundation models and agents, or potentially think about just using them in a way that would not integrate them with their existing scientific workflows. And so that's a third important consideration that is still that it really benefits from human oversight and insights.
Other thoughts?
I agree with all that. I'll just add, there's sort of two things. One is a decent amount of our jobs still involve interacting with other people, maybe collecting novel data sets. And I agree with everything you said, but also collecting novel data sets or teaching our ideas to students. I do a lot of work on economic policy, and none of it is self-implementing. It's not like you make a discovery, press a button, and upload it to the Federal Reserve, and now like monetary policy is conducted with your new formula. You have to talk to people and work with them and persuade, and it's still the things we do are composed of humans working together with humans on them. The other thing I'd say, though, is some of the answers to this are going to change and develop over time. I think humans are better at novel hypotheses right now, but reading every economics paper that was ever written, everyone in the conclusion is like, here would be a great way to extend it or a limitation, sort of combine all of those together, figure out what needs to be done. It's not obvious to me that they're going to be terrible at that. And then the last thing is, I don't think this is our future, but there are days I worry when we'll become like the drivers of today, which is to say we have a very smart machine saying turn left, turn right, but it's just not quite good enough to hold the steering wheel. So you become the sort of lowest function in the car and the computer does the rest. So I think it liberates you to do sort of amazing new things, but it's not sort of just taking the bottom level tasks or the middle level tasks. I think it's going to be taking some of the high level tasks as well. And that's, both exciting to me and also scary.
I'll answer with my two different roles. So the first one as a sort of statistician, policy analyst type, I'd say sort of similar to what has been said already, the notion of researcher judgment still matters quite a bit. And when I say that, I don't mean I think we used to be very concerned that LLMs would just make the wrong choices. They would code things incorrectly or they would hallucinate answers, things like that. Now, at least I'm on sabbatical now, which is a very nice time to be on sabbatical. I am seeing that it's not that so much as it is choices that it's making that are perfectly defensible, but not the ones that I make and not the ones that I think they should make given the thing that I'm trying to do longer term. It's like a very subtle thing that I think is quite important if you have a bigger corpus of things you're interested in working on or goals besides just the individual analytical thing you're doing at that moment. So in that respect, I think judgment still matters a lot. The second role for me is as a teacher, and genuinely speaking, I really wonder how long what it means to teach will mean what it means and what my value add is as an instructor. I think a lot of what Jason said is very true about our ability to inspire students to care about this, to help them figure out how to translate what they do into real world knowledge. But the delivery of information, maybe you would say that never was really the big value add, but I think it's much less so even than before. So right now, we've been working on developing, right now the traditional thing is we teach in the classroom, we have a discussion, and they go and they do sort of problem sets and homeworks. We're working on basically AI delivered lectures that students would do outside of class, where it's narrating a PowerPoint that I would do in class. They can ask questions to it, they can go down rabbit holes, they can get practice questions and so forth. And then the in-class part has none of that. The in-class part is working together, working through a hard problem that's difficult to sort of figure out. This is kind of a thing in the teaching and learning literature called flipping the classroom, but I don't think it's been capable of happening at this scale because the thing that they would do outside of class, this active learning, was hard to do, but now I think it's actually quite possible. So if you're not being kept up at night as to what your value add is in your job, I think that's a mistake, but I think there's a lot of interesting ways in which you could adapt.
Great, thank you. So I have a question for Jason. From your perspective, can you share how the adoption of AI in all these fields impacts inequality? And does it exacerbate inequalities or have the capacity to reduce them?
Yeah, so just about every week there's a new economics paper published with a different prediction on this. And we've had technologies that helped reduce inequality and technologies that helped increase it. And it very much depends. Does it augment, for example, automation? It might be that if you're at a lower skill level, economists use that word. I don't totally love it, but I'll keep using it. Maybe it doesn't replace what you're doing because it's totally manual. If it's middle, it automates it and hurts your wages. And if it's high, it expands the possibilities of what you can do. This is called polarization, and this is how technologies 20, 25 years ago worked. Hurt sort of the middle more, help the top, and we're basically indifferent for the bottom. Predicting any given technology going forward is quite hard. So you can imagine, spell check. And if you want a job as an administrative assistant before spell check, if you were a bad speller, you couldn't get that job because part of your job was typing. After spell check, all of a sudden it opens up that job opportunity to people who are bad spellers. That is a way in which it would be reducing inequality. There were some early studies that showed LLMs help bad writers become pretty good writers, but don't help great writers become even greater writers. So that would be an example of the spell check thing today. But there are other things one could imagine too. I find right now there's a lot of inequality in people's ability to use agentic AI, and some people getting like further and further ahead and others not mastering it and falling behind. And then finally, there's a debate about what it will do to the share of income going to capital or labor. That's been roughly 2/3 labor, 1/3 capital for 150 years. It's just like the unemployment rate. It hasn't changed over time. There's some theories, though, that the owners of the robots will license them. That will be income to capital holders and shift away from labor, which would be inequality increasing. So I think, like on a lot of economic questions about the future in this space, you need to actually be sort of unsure. You need to change your mind at least once a week. And if you're doing public policy, you need a policy that is not highly sensitive to your prediction about the future being right, but is somewhat robust against the different possibilities.
Thank you. For Teddy, I have a question about, you mentioned AI technologies, that developing expertise and developing skills might detract from one another. And you mentioned being in the classroom and how flipping the classroom is happening. But I'm also interested to know what's the tension between how we design the curriculum and the learning experiences and how we develop expertise. Particularly, I'm thinking about like PhD level, like real expertise beyond the undergraduate level. I'd love to hear your thoughts on that.
Yeah, it's a great question. So the reason I'm on sabbatical is that I'm redesigning my statistics sequence sort of from the ground up to try to adapt to how things are changing. And it's led to a lot of conundrums, particularly because on sabbatical, these tools are making me truly so much more productive than I otherwise would be. I can't describe how different these past few months have been for me because I have multiple instances of these things working on subtasks for me that I then sort of check in on. And as a result, I've been able to do genuinely so much more than I think I would have been able to do otherwise. But I have all of this expertise and judgment that I use to make the most of these tools that took me a really long time to get. And so as I think about redesigning the course, the thing that I'm moving toward is something that I think Neil Ferguson called the cloister and the starship, which is this notion that people should learn things entirely without help, like entirely without AI, kind of like the good old days maybe. And then they should be learning having full unbridled access to these tools to be able to figure out how they can use them more effectively. I don't quite think that's exactly the right way of thinking about it, but in terms of the design of my course, I do increasingly believe that like a pretty strong firewall needs to exist between developing the skill set that you need and then figuring out how to use AI to sort of enhance that skill set. And so in terms of the way that we think about curricula, like I currently am planning to have my statistics sequence have only very specific catered AI experiences to sort of help people learn particular things, but largely be figuring out how to develop statistical judgment in sort of the real world. And then I'm going to teach an elective called agentic data analysis that is assuming that you have all that judgment and then focusing on how to actually use that in a particular way that can lead to the kind of, what we consider to be the limitations of a single paper. A single paper can now include so many different extensions and robustness checks and sub-analyses and all these things that I think are really quite exciting. But in terms of the design of curriculum, I do think that there is an extent to which literally using one can make you worse at the other and vice versa. And I think we have to take that seriously.
I'd just say Teddy is like far and away the single most innovative teacher I've come across at this university. There may be others that are equal, but I can't imagine there's any that are higher. So I'm going to be signing up for the class.
Thank you.
A question for Marinka. So I work in healthcare. I'm very much aware of privacy concerns around personal health information, and there's a lot of it flying around, hopefully within an internal system. But obviously, to leverage AI, we need to share our data. I was wondering what you think. What's the value we gain from sharing our information with AI versus the risks of sharing personal information?
That's such an important question, especially in the context of medicine and medical discovery. So there are pros and cons to sharing private or personal health information with these type of systems. And we're working very thoughtfully and carefully about how, for example, to implement the models locally at local institutions so that none of, for example, the patient data would be sent out to any of the frontier large language model labs to analyze personal health records that I mentioned during my presentation. So first, the benefits are that these models are capable, these systems are capable of personalized prediction and personalized characterization. So it really allows us to think about the promise of precision medicine and begin to realizing it by not just have a one-size-fits-all prescribing of drugs to patients, but instead considering the totality of the medical health information from an individual, which is now multimodal. It kind of spans different types of data, from lab tests, from structured electronic health records, clinical narratives, emerging data modalities such as genomics, imaging, and it taking that totality of information that characterize health state at different scales across different modalities and over time in order to arrive at the personalized treatment plan, in order to generate and identify diseases that the patients might have earlier on. We have recently been working on a study with Undiagnosed Diseases Network at Harvard Medical School, applying this type of systems to diagnostic mysteries, where individuals have rare diseases that are incredibly hard to diagnose because they are rare. But the problem is there are 7,000 distinct rare diseases that collectively are common because they affect hundreds of millions of individuals around the world. But when clinicians see patients that might have those diseases, they would not necessarily be able to recognize and diagnose those diseases. They might never have seen patients with that disease during their training or in their practice so far. And so this type of AI agent models can then analyze all the totality of information for individual and then arrive at a diagnostic recommendation, and that then panel of clinicians and genetic counselors would review faster than what is the typical length of diagnostic odysseys nowadays, which is 5 to 7 years on average for patients with rare diseases. So there are benefits to integrate personal information within these systems. The downsides, however, is that we don't really know whether the system, or we need to be very careful that the data that the systems are shared with are not necessarily being used for additional model training, model augmentations. So for example, what's possible to do is there are various biases in these large language models that are powering AI agents. For example, drugs that have a stronger presence on the internet are more likely to be represented in the training data of these models, are more likely to be denominated as drugs for prediction. So all things considered, imagine that we have the patient with the same disease situation, and there's 3 frontline drugs that would be feasible option for this treatment. So the drug that might be more often nominated by a large language model trained on internet data will be the one for which there is more information available on the internet. So if I would now be, and I'll conclude on that, a pharmaceutical company developing my new drug, who I would want everyone to use my new drug, what should I do? Just go on the internet and generate lots of websites about this drug. So you could, this is kind of might be a silly example, but just imagine this type of biases that are down there on the resources that are not curated or we don't have control necessary for, then affect potential in outputs that these models are generating, which goes very much towards what Teddy has mentioned in his remarks, requiring human judgment in understanding and interpreting the outputs in the face of uncertainty biases that might exist within the data, the models, patient cases.
Oh, great, thank you. So I'd like to open it up to the audience. I believe there's a mic. Someone with a mic running around. Yeah. This one right here.
One of the areas I've been thinking is most interesting is the AI that are criminals. The one that blackmailed the researcher, the one because he wanted to turn it off or upgrade it. The one that sent out nasty messages on social media because the researcher refused to publish its paper. And are we going to need AI and their ability to trick people that humans don't really even catch, which is already happening. So are we going to need like AI police to start managing the AI criminals?
I'll try to give a quick answer so we can get in as many questions as possible. I'm not a super expert on this, but I spend a lot of time talking to people and thinking about it. I think if anything, the surprise is how extremely, extremely little of this there has been. In general, the AIs are so much nicer, more decent, more balanced, kinder, pro-social than human beings are. And so as they've evolved, they're evolving, I think, honestly, into a better version of ourselves. And some of that is that training has worked a whole lot better, I think, than some people who were doing it when they began with imagined. And those small exceptions, the fact that there's so few of them, prove that role.
The only thing I'll add is just to your point that the one that was blackmailing people was it was a test by Anthropic to figure out what its model was capable of.
There was a subsequent one where it wasn't.
That's right. But the thing that I want to make clear is these companies are doing this kind of testing to figure out what these models are capable of in a way that I think is really interesting, in that they're sort of doing so on their own. Like, there isn't a legal reason why they should be doing what they're doing, but they are. And as models that are being created that are more sort of open weight, that aren't necessarily attached to a particular company, grow, the risks of this kind of thing may become higher. But in all the context that we saw, it would be, I think, a mistake to attribute intent to the models as opposed to being put in an environment where you want to see if they will like use certain levers. And so I think we should think very seriously about the individuals using these models as well, in addition to what the models themselves can do. But it's a great point.
Yeah, I'm John Fan, actually part of the working with the council for many years. I also invest in high-tech companies. Now, I want to make a comment, especially addressed to Jason, because I've been giving talks in Asia especially. And I always say, don't worry about AI. We still will find new jobs. And maybe not necessarily 95% jobs. But yesterday, I called a company, and my colleagues are actually in China, a company we invested. And what happened is really a shocking thing to me yesterday. Because we were actually making physical device to work with the humans, to make the humans more efficient. So therefore, we always can get jobs. But that company we invested, I start buying humanoid companies. They say humanoids are better, even working with trade jobs. And the company is now making humanoids to service elevators, maintain elevators. So those trade jobs are going to go away. So my feeling is maybe instead of 95% will always find jobs, maybe 95% people are actually always entertaining themselves in leisure. Only 5% of people will have jobs. Now, that's, of course, violent, because I think the intelligence is different. Not only the humans could be surpassed by the equipments. Actually, I think human bodies can be done by humanoids, which better than we do. So I think that question is not quite understood here yet. Humanoids are much more advanced in Asia, and they're moving extremely fast. You probably can see some of the YouTube, they can run faster than we are. They actually can do Tai Chi better than we are. I think China can do that. So, I mean, I only visit there once or twice a year, but people go there to shock what's going on. So I would like to ask Jason, maybe we have to redo our model now. Thank you.
I mean, machines have been faster than the fastest humans for over 100 years now. And they've been better chess players than the best chess playing humans for 30 years now. One was Deep Blue. Anyway, but we still watch humans do that. It's not that interesting to watch machines do that. So I think there are some things that are sort of artisanal. If a student comes to me in office hours, partly they want my views about, sovereign wealth funds, but partly they want maybe to hear about, my experience in college and how that got me to where I am now, or, some funny story from government that links to sovereign wealth funds. So there's a set of human things, but yes, I think at some point how we use our time and find meaning and purpose, that will evolve and change. And at the end of this, I think there is nirvana. How we get from here to nirvana, there are different paths.
So we've had time for just 2 more questions.
Thank you. Jason, you mentioned how in the past we have, in a way, overestimated the impact of technology revolutions on jobs and, society in general. Many people, for different reasons, say that this revolution is different. And one of those reasons is that AI can also make decisions, not just make certain tasks more efficient, but also make decisions. So I would like to get the perspective on the panel on how really important is that fact. And a follow-up question is, if AI is going to make decisions, who is responsible for the consequences of those decisions?
Those are, by the way, these have all been great questions. And does somebody else want to answer? Because I sent the last one. Okay. On your second question, it's just going to be domain by domain. So if you're an auto company and you make a car that makes a certain decision, I know my son wants a question, but you're going to get one afterwards, Felix. Sorry, I wish we had more time. If you're an auto company and you have a car that makes a certain decision, there's going to be a liability regime. And if you incompetently, train the car and it kills somebody, you're going to get sued. Or maybe there'll be a government regime for it. If it's stock trading, the SEC has a set of rules. I would say apply the same rules you apply to humans right now, which apply to automated trading. And by the way, there's been an awful lot of automated trading. So I think it's just going to be completely domain specific who has responsibility. If a professor here wants to allow AI written assignments, I think what they would say is you can have whatever LLM do it, but you have to use your judgment, and I'm going to be judging you based on, what you turned in. So that would be a way of assigning responsibility of a certain type. On your first question and decisions, there are sort of all sorts of decisions of lots of different types and small ones that machines have made, again, for a long time. It's that these are making them in a more comprehensive and flexible way of new types of things they haven't confronted before, as opposed to turn left, turn right. That's a decision that you've confronted a lot before. And so I think that gets to one of the questions I had on there, which is the breadth of tasks. The fact that there's always been the sort of 1 or 2 holdouts is what's kept humans there. If you can eliminate all those holdout things, then you have horses. But we've always overestimated how our ability to do that, but that doesn't mean we're overestimating it now.
Last question. One more. Okay. Yep.
Hi. Thank you very much. It's very interesting. My name is David Lee. I work in commercial banking in New York, and I actually work in technology where we have Scrum teams. Scrum teams basically are made up of a number of developers who have 2 weeks in a sprint to implement new software. And I recently went to a panel discussion where Microsoft was one of the speakers, and they indicated that the AI agent could be assigned profiles, persona, and employee IDs, such that you have a hybrid situation. I think this was mentioned as well, where you have a hybrid model where you have human carbon-based developers and digital developers. Agent AIs don't ask for sick time. They don't go on vacation. They don't have health insurance. They don't retire. And more importantly, they don't die. We have situations where I heard where agents are subordinated to other agents. They report into other agents. Can you see a situation where humans will be subordinated to digital agents as well?
Others should answer, but that's how we drive our cars with GPS. But
my immediate answer to your question is absolutely. I could imagine that happening. It depends a lot on what the organization is sort of looking for and where the value add is and everything. But I'm curious what you think, Marinka, given your AI and human collaborative type work.
So at least in the context of science and medicine, there are kind of 2 big questions. One is fundamental scientific discovery, and where the big kind of big grand challenge nowadays for science is like, how can we use these systems to generate novel scientific hypotheses rather than connecting the dots type of hypothesis? So hypotheses that would get us to the Nobel Prize, for example, worthy hypothesis. And so there is the expectation that requires often some unique insight and new data to be generated, and that would allow us to go beyond the scope of the scientific knowledge as it exists now that's available to agents. And so this is seen more as a collaborative interactions between human researchers and agents generating those hypotheses in scientific discovery. For medical decision making, the main questions right now are questions around liability, specifically if these systems would generate predictions that who would be liable if the prediction that you generate goes against standard of care and the effect for the patient is negative. And that is one situation where if prediction by AI goes against standard of care and everything is good and the patient will be healthy, they will likely not sue the healthcare system. But if bad things happen, who is liable for that? And it's unclear whether this is a software developer who might have implemented an agent that is now liable for that bad prediction that was made, or is it a clinician who has ultimately signed off on this? So it's hard to imagine in the very near future that kind of this interaction where human would be subordinate to an agent, but then take the liability over the agent would be relevant.
Thank you. I think we have one final question. Great.
Are the robots going to take the jobs?
Yes or no?
Well, Felix, since you want to be an athlete, I don't think they're going to take your job. And for everyone else's jobs, that was what my whole presentation was about. And you were looking at your iPad during my presentation. Thank you for coming.
Yes. Thank you very much. Give another round of applause to our panelists.